So in this video, we'll be looking at questions that ask us how we can calculate the derivative of a given function. So let's look at the first one here. So let's say we're given a function of this. If we look at number 1b, we've given a function is 3x cubed minus 2 all over x to the power 4. So in order for us to find the derivative of this function easily, we need to change the way this function is written into 3x cubed minus 2x to the power minus 4. We know that 2 all over x to the power 4 is the same as 2x to the power minus 4. So once we have our function in this format, we can easily apply the formula at C to find the derivative of the function. So these questions are usually built upon the previous question. So you may find that the second question asks us to find the gradient of the tangent. So this question requires us to remember that the derivative that we found on the first step here gives us the gradient of the curve at any given point, and the tangent touches the curve at one point. So that means the point where the tangent touches the curve is that point, the gradient of that point is the same as the gradient of the tangent. For instance, if we look at the graph on our right hand side here, we have point A. The gradient of this curve at point A is the same as the gradient of the tangent. So that gives us that easily gives us the gradient of the tangent. So once we have the gradient of the tangent, we can be asked to maybe find the value of x at that point, or the value of x anywhere, or the equation of the tangent. To do that, we refer to the equation of the line, which is y is equals to mx plus b. So we will have our m, we will have our y and our x, and we may be required to find b. So we just substitute the values of y, m, which is our gradient, and x, and then we solve that equation to find the value of b, and then we have our equation for the tangent. We apply almost the similar principle when calculating the gradient of a normal. So now we have to remember that the normal line is the line that is perpendicular to the tangent. So if we have the gradient of the tangent, the gradient of the normal line is a negative reciprocal of the tangent. Yes. So the gradient of the normal line is the negative reciprocal of the tangent. So that means that if the gradient of the tangent is m, our gradient of the normal line is going to be minus 1 all over m. So again, given the gradient of the tangent and the coordinates of intersection, we can easily find the equation of the normal line by substituting the values of y and the values of x, of m. In this case, our m will represent the gradient of the normal line, and we then solve that equation to find b. So that's all I have for you for this kind of questions. Please see us again on the next couple of videos. Thank you for watching.